Afternoon all. So now we have a Deepak Mahto from DataCloudGaze Consulting, and he's speaking on accelerating PGSQL code conversion on migration from another database. Please welcome him.
Thanks a lot, yeah. Very good afternoon, and hope you all are enjoying the talks that is happening in PGConf 2025. I'm enjoying every moment of it, and thanks for joining on my talk. So it's primarily on migrating to Postgres when you come from a different databases like Oracle and SQL Server, and all of those migration is always time-bounded. It's very important to have acceleration on what you do as part of those migration. And with me working with a lot of enterprise customer, I want to share all the learnings that you can capitalize to accelerate the migration, primarily on the code conversion part. So I'm Deepak Mahto. I like to call myself as a database guy. I was working for Google and Amazon before starting my own venture, which primarily work on migration. So if I talk about a typical migration phase, it revolves around assessment, code conversion, then testing, data migration, and the validation or last cutover. But if you talk about the case where you have a lot of code logic embedded within the databases in the form of procedure, function, packages that you see, it takes up a lot of considerable time. So if I talk about a databases which has a lot of code in the code logic itself, because if I talk about the implementation that we have done from last 20 years, I was doing an implementation 15 years back, I used to put a lot of logic in packages. So there are lots of legacy systems that still have a lot of code engraved as part of the code logic that we have in databases. For such migration, almost 50% of your effort will go on mitigating conversion or the issues that arise because of that. So it's very important that if you want to accelerate the overall migration, you have to accelerate the conversion phase of it. And talking about PGSQL, one of the facts about PGSQL is that it itself is an extension in databases. So whenever you create a database, by default, you will have PLPG as a trusted language extension part of the database. It is because it is part of template 0 or template 1 database that we have. And it comes inbuilt as part of all the installation that we do on any cloud, self-managed everywhere. And to talk about what a structure of a PGSQL look like, it follows a block-oriented architecture. It has a structure which we declare the data area in declaration, and it has a begin end. So don't confuse this begin end with a transactional begin end, but it is more of putting a logic over here. Now, if you look at the slide, I've shown two sections. Left-hand side have put the logic on the string, enclosed in a quotes. On the right-hand side, we're using something as dollar quoting. And this is one of the very important distinguish of putting logic in databases as part of Postgres. So whatever we write as part of function, it got saved as a string in pgproc kind of template. So this is very important differentiation that we should be well aware of it. So when we talk about conversion, most of the time PLPG exhibit a lot of characteristic which is similar to other procedure language, like PLSQL or TSQL. But that similarity is not what make it more compatible, but we have to understand what happened when we actually execute and how it differ as part of execution that happen in other engines. It's very important to understand that differences. I'll talk about some of the challenges which cause an increase in time, right? So as I mentioned, whenever you put a code on a procedure, it is enclosed in a string, which means that it does not do a lot of validation as part of compilation. Compilation is a process where you'll do a lot of syntax and semantic checks, but one thing that differ in PLPGSQL is it will not do a lot of checks as part of semantics when you compile the function. And if I just take a step further, right, this is another example. If you look at the highlight portion in the slide, it refers a column which is not present in the code or it's not present in the table itself. It means that whenever you have reference to an object that does not exist, such code will also get compiled. And trust me, this was one of the big surprise for me as well, because I'm someone who has worked in Oracle for 8 years, and understanding that compilation differs, this brings up a lot of difference in the process that you do. So that indirectly means that whenever we have a compilation, it does not do a lot of checks as part of PLPGSQL. And coming from a database like Oracle, what used to happen is, if there are different procedures and packages, if I change a single code logic, it will have an understanding of dependency of it. I think if some of you, if you're Oracle background, does you know what is DB object table? it has a column which represents the status of the object. So whenever you do any compilation, all the dependent objects become invalid, and the process is to recompile it. But because of this limitation, in Postgres, there's no dependency. All the objects are loosely coupled. It doesn't form any dependency as part of language PLPGSQL. Hence, whenever you have a lot of code logic in databases, it's very important to understand that whenever you define your definition of done as part of code conversion, it's not compilation. So next time if you're working on a complex code and it got compiled, don't jump and say that my work is done. That's when the actual work gets started. And that's one of the very important difference for the folks coming from other databases to understand. Now, if you look at this code, I have written it in if-else block. So it means that it has different entry point, and if I want to have 100% code coverage for this sample code, I need to follow and enter all the clause, right? So if I pass 1, it will go to a different section. If I pass different value, it will go to a different section. Now, it intentionally has a lot of error as part of compilation, right? So every block has missing function, missing table, and all of those. And if I go ahead and compile it, it will basically get success. But one thing to note over here is, whenever you do your first execution, that's the time when the actual statement get processed and parsed. It's not during compilation. So compilation does a minimal checks for validation, but it will not do all of those. But also one thing to note is, if you look at the input that I have passed, your first execution of the code will not give you all the errors. It will only give you the error for the block of it. So if you look at the output over there, if I have 1, it has given me error only for that block. If I pass 0, it has given me only for that block, and -1. So that means that even if you execute your code after compilation for the first time, it will not guarantee 100% code coverage. That's one of the difference. So hence, whenever you have a conversion, it's very important that you should understand the difference and have some solution around it, which we'll talk as part of the subsequent section. This is some internal representation. So in Postgres, whenever you create a function, you have an option to dump. Dump is basically how the internal representation happens for a function. Whenever you compile a function, it creates a data area. Data area holds all of the variables that you have defined on it, and also it basically parses your statement and expression. So one more important differentiation is, whenever you have any expression in PLPG block as part of if clause or an assignment, internally all of those transform to a select query. It's not an expression of its own. It means if I have a condition like if A equal to B and then I put AND, that seems to be an incomplete expression, but that AND will become alias for the query when it got transformed to select. So that's very important distinction that we have to understand. And can someone highlight me some fun fact based on the highlight? Can you see some additional variable over there which got added up as compared to the code? You'll find that there's a found variable, right? So that's a special variable that you'll see automatically getting added to your code, along with your other data area. At the same time, you have tree node based on the structure, and only those blocks are. So in short, PLPGSQL is an interpreted language. It doesn't do a lot of check during compilation. And hence, it becomes an important consideration that whenever you're doing code conversion, definition of done should not be compilation of code. It should involve a lot of steps, which is a proper planning, data type consideration, early validation through first executor, and test cases. And over here, I'm not introducing an AI tool. It's all keeping back to basic that we all know, right? So the very first thing is conversion planning. Now, in most of the case of conversion, you actually come from source, which is on Oracle or SQL Server. It's very important to leverage those data points from the source itself. And some of the data points for planning are line of code, the objects that you have, how many triggers you have, views, function, all of those. So the thought process should be, how best I can leverage the metrics from the source itself to build some data point. Line of code is one of the very important data points when we talk about code conversion. For one of the customer case, we were migrating close to 1 million line of code. That seems to be a lot of logic, right? So you have to better understand what are all of those engraved as part of the object and all of those. And look at this graph, right? So it's very common saying, right? If you have a bigger problem, throw more people to solve it, but that's not always practical. And that's very true for code conversion as well. There has been cases where you have lots of code. It seems that if you add more people, it will solve the problem, but that's not good. Let's take an example, right? So if you look at the slide, your call stack in database is not limited to one single code. It can have a traversal. If a person is working on conversion and he or she does not understand the dependency, if someone is working on procedure A, they cannot complete the conversion unless B, C, D is done. If someone is working on B, they cannot complete the conversion unless C is done. So it's very important to understand that you have to start your first candidate identification. And the first candidate is the code object which is not dependent on other code object except tables and all of those. So that's a very important consideration. So you have to find your first candidate and subsequently move it. Now, when we talk about Oracle or SQL Server as a source to migrate from, they have their own views to give you all of those information. If people coming from Oracle, they will be aware of DBA dependencies, all dependencies. If you're coming from SQL Server, it has its own DM views or SP depends. You have to leverage those and understand the dependency from them. And once you have those understanding, you have to bring in some more metrics. I'm giving an example where we have a week-wise plan, and it's very important to put a governance on code conversion as well. So if I want to migrate on a 10 weeks, I should know every week how many line of code I should burn. When I say burn, it includes auto conversion along with the manual effort that you put in. And it put a governance in place, process in place that give you deliverables that you have to achieve for each and every week. So it means that if I'm on week 5, whatever object I'm working on, those dependent are already taken care in week 1 or 2. So you're resolving your dependency first, and then moving forward, backward, or forward. And over here, you have to create a sequence for the team to do it. When you have such kind of code conversion planning, you know the sequence in which you should do conversion, you can scale with a larger team. Because you're assigning code for them to work in an order. It's not random. And it's very important to have this understanding because in migration, if you want to tackle a complex or a legacy system that has lots of code logic, this all need to be in place. Okay, so this is part of the first section. And I always say this is code conversion is actually a development, but the process is mimic the functionality exactly similar as source. Right? So code conversion is kind of development, but mimicking what is already there. Let's look at this example, right? So this is primarily for putting a code logic where if I pass an input string as empty string, it is basically going and processing that is not null. But let's think about its implementation, how it was done in source. In source, like Oracle, empty string and null are same. So if you pass an empty string, it should have gone through the first if block. So in a way, because based on input, your functional checks varies. And it's very important to mimic the same behavior in source as part of target. So you'll fix it like this. You have to understand this difference. This is very minute difference, right? Empty string and null sounds to be technically very smaller difference, but an issue like this can cause a lot of rework. A test case is failing for empty string. It is going through a different conditional block. The whole workflow, which was functionally supposed to do some task, it is doing something else, right? So it is a very small thing. So what I'm trying to say over here is conversion is also about knowing the source, but also knowing the target PLPG-SQL. So you should be aware of what are some of the PLPG tips that we can use as part of conversion. If I move further, PLPG as itself offers some more flags that can improve your development experience, deployment experience, and all of those. So I'm just sharing some of the flags that PLPG offer, where you can use some additional warnings or error as part of executing function or as part of compiling the code that we have. It also includes additional parameter where you can get output whenever your select into clause fail because of no data found. So you can use all of those parameters as part of your development or conversion process. So the thought process is leveraging what's the best of PLPG-SQL as part of conversion. So if I just show you a sample over here, as in when you enable the warning flags as part of your session, you don't have to do it at a DB level. You can set it at user context, which is for your session. And whenever you're running code, you can get additional error. So if you look at the error that we are printing is, it's around shadow variable, like some variable is eating up other variable in the same scope with the same name, or are we running more than one rows and all of those. So PLPG have this flags available as part of configuration. It's important to leverage those as part of conversion as well. Now coming to this example, right? This is, if you remember the previous slide where I talk about, it's important to have a dependencies. So what happened in Postgres 14 is there was a new feature introduced called as atomic function, where it became more intelligent as part of compilation itself. When I say intelligent, it means that it started capturing more metadata that it need to be aware of. Now if you look at this example, over here I'm defining a dependencies as part of compilation itself. Now over here, if you go ahead and drop the function, it will not drop it because it knows it has some dependency. In Postgres, currently the dependency checks is limited till views and all of those components. It's still not part of the PLPG block because of the string nature of it. And if I just go more technical around it, so now what is happening with atomic function is, as in when you do compilation, it builds additional metadata as part of compilation and use latest column, which is pro SQL body, and in a traditional way, it used to go in different column, which is PRO source. So basically, it additionally have some information. So if you look at the function ID, which I'm highlighting, it is actually knows that which function expression I'm calling from this function. So this is something that got introduced in 14. But important to highlight over here is that there are a lot of conversion tool in the market which does such kind of conversion, but they don't leverage the newer feature of PLPG yet. The tool is not smart enough to make the decision that the language should be SQL, it should be atomic. It is more in concern of mimicking and executing similar syntax of what you see in Oracle as compared to Postgres. So it's very important to use some of the features like this as part of your conversion lifecycle also. Because conversion itself put a lot of effort, and it's also a time to modernize some of the things which was built in past 15 or 20 years back, right? So this all feature help you to do those as part of it. This is again some more section, right? So if I talk about, if I need to do something back in Oracle days, Stack Overflow was something that used to answer a lot of stuff as compared to today's era where you have LLM. So if you search for how to split a string based on a delimiter, there was some standard example output which was there available in Stack Overflow. Now this is one of the examples where if you take code as it is, and if you're converting it literally with the same syntax, because if you look at the code, it is using some fancy hierarchy query connect by level. If you try to convert it as it is, it becomes tricky. Sometimes it's very important to work a bit backward, understand what exactly it is doing. You don't have to push yourself to achieve exactly same code, but sometimes it's important to achieve exactly same functionality. So if in such cases, it's important to have those mindset where you'll go back and understand how things, what is the input and output, what actually the function is doing. So if you look at the example, if you try with different example, it's basically counting the number of values based on delimiter, right? Now, once you understand this requirement, it's very easy not to convert the whole code, but use something which is readily available as part of PLPG/SQL or as part of SQL family in Postgres, right? So you can use those features, all of those libraries directly. But if you try to convert it, it becomes more tedious. So over here, we can use regex split to array, cardinality, which are all available as part of Postgres feature itself. So what subtle art of conversion says is, sometimes it's better to work backward, understand why the code was written, and sometimes you'll find such common code available in legacy code. And not all the tools are able to convert those because of the complexity nature of it. Now, this is very important for a lot of folks who do migration, right? Because the decision that you make as part of your data type mapping, it's very important. Because some databases like Oracle or SQL Server, they offer their own implicit casting for text, int, and all of those. But when we talk about default operators in Postgres, they don't do it. Same numeric family cannot do a direct implicit conversion. It has to add up like the operator has its own casting way, but it is not available as compared to the source. So the data type decision is something that we have to take cautiously, and emphasis need to be done. Because whatever data type decision we take as part of tables, columns, they have a bigger impact on procedure code. Now, over here, if you look at the example that I have, if I do a simple count, the default data type that Postgres assumes is begin. It's not integer, it's not numeric. Now, if your application code says is integer, it will not work. So such differences, if you look at examples, there are some data type decision that Postgres takes on its own. An empty string and null both are text. So all of those is very important. And if you part a constant numeric based on the size or the length, it chooses a particular data type. And data type are some of those few decisions. Those not only impact the issues and all of those, but they also impact the performance part of it. Because if there's any casting and all of those, so if you look at this example where if you try to match up a numeric with a different family, it internally does the type casting. If you try to match up it with a different thing, it will do failures and all of those. And data type issue is some of the very common issue that you will solve a lot of time post-conversion. If you're solving it during the conversion phase, that itself the time will be very less. But if you're solving it once you give it for testing, the time increase. You have to find where the issue happened, the call stack, and everything. So it's very important that whenever you do any conversion, put a very important emphasis on the data type mapping. I'm giving you a sample example of one of the data type mapping that we have. This is from Oracle to Postgres. You'll see different number families need to map to a proper number family over here. At the same time, very important consideration need to be given to columns which are primary key and foreign key. Because those are the columns that you'll see have a lot of joins. They should all fall in the same family. And these are also the time where you can take a very better decision from the perspective of data type. Like for primary key column, we can go for a begin family as part of modernization migration itself and not choose an integer or some other data type. At the same time, based on number characteristic, based on precision and scale, you can decide which family of Postgres you should go. And for some cases, you don't have an exact support of data type. Like one of the problems very known in Oracle to Postgres is Oracle till 23 version didn't have a Boolean data type. So what Oracle used to do is to use character Y and column 1 for storing Boolean value. And the ORM layer or application layer were well aware of it, which were built on top of Oracle. But when you switch to Postgres, sometimes it fails. So it's very important that you do those Boolean transformation also as part of your migration. And this becomes the source of truth for the folks who are doing conversion. They should rely on the data type mapping decision that you have done. Because henceforth, whatever code base we choose, it has to have exactly same resemblance based on the table column that you are referencing based on input argument. This is again an example which is very common issue if you are not very cautious during conversion phase. So if you declare an integer function, you pass begin, numeric, or double precision family, it will say function does not exist. We had a case where the line of code for conversion was only 500 lines of code, but it took close to 2 to 3 weeks to fix all of this issue. And it became tedious because you're not being, we were not very cautious during the conversion phase itself. So over here, I'm just showing a tabular representation where it basically shows you what data type decision you take and how much mapping it is. Now this also have that, if you look at double precision, it is showing an implicit, it can be work for all the data type, but that's not a right decision to take. You should always rely on where the argument is used. If it is passed as a filter to column, you have to map that data type back to the function argument. So it's not that if you choose double precision, your problem is solved. So this mapping is also very important consideration as part of what you put as part of function argument. Now, when I talk about acceleration, it's also very important that you standardize some of the things that you do in migration. And we have to wrap up some of the common issues that you see as part of the migration itself, because in migration, an issue can happen multiple times, but the fixes can be applied once. And the best conversion is actually no conversion. So if you wrap it up, you can save a lot of time, and you can standardize the process. Now I'm giving you an example, and this is a real case. If you have a date-based function, let's take a very simple function like 6date, and if I ask 4 different people from Postgres what should be the equivalent in Postgres, someone will say now, someone will say clock timestamp, someone will say current timestamp. Everyone will choose their own variant. And there's no standardization to it. But if you look at the output, now is actually a stable function. And clock timestamp is a volatile. So within a single transaction, you will get same time every time or varying time. So if you look at the output, for now it is same. Clock timestamp, the time increase in the transaction. So I'm showing an output within a transaction. And this also gives you a different behaviors. Now if you don't standardize a basic function like sysdate, and if you have a bigger team, everyone making their own decision, so everyone is feeding something which can cause an issue at a later stage. So it's very important that you standardize thing, wrap it up, so that you define how the migration should look like. And my advice is standardize as much as possible. If my migration involves a feature which is extensively used across the code, you'll standardize it with wrapper and all of those. Now, one of the extensions that is readily available for and also supported in most of the major cloud provider is Aura FC. Now, a wrapper like Aura FC help you standardize a function. So the guidelines that we can set for the conversion team is, don't bother about traditional functions that you see in Oracle. Let Aura FC take care of it. And that's where you create standardization. You avoid issues, and you're not letting an engineer decide it, but you're standardizing for the whole team. And Aura FC help you to do that. At the same time, it's very important to take some of those and standardize at a larger scale. So for some cases, we have standardized UTL file packages, which are very much used in a proprietary databases like Oracle, or for SQL Server, some date-oriented function. It's very important that if you standardize those, the issue that can happen because of it are limited. And the more you do as part of migration pattern, more acceleration you do, because the team doesn't have to take care of those functions. You have already taken care as part of wrapper. When I say wrapper, it means that you add a function of the same name as your source, but it execute as per Postgres PLPG structure internally. So the individual doesn't have to take care of it. Adding to some more point, right? So with this concept, there are already a lot of tools that introduce something called as extension pack and all of those. But you should be well aware of this, because sometimes an extension pack, which is provided by some of the providers, can create an additional logging. And see, one of the goals to migrate to Postgres is freedom. Even if after migrating to Postgres, we have some kind of logging, it doesn't serve the whole purpose, right? So it's very important to have those. So you should be well aware of some of the extension pack that create of those. So I'm just showing one of the tools that we have where if you use those tools, those extension pack can be removed, and you are actually using a solution which is more compatible with Postgres than some extension pack which is a proprietary solution. Okay, and see, as we all know by now, I hope by all of you understand that the Postgres itself compilation will not do a check. So what solution we have? So thanks to our community, we have some of the extensions that can do some checks. So this is a linter tool. It can have a false positive. It does not guarantee that it checks all an error. But pgSQL check can be something which you can run for your code, understand what can be the runtime issue or first issue, because the first execution will give you an actual issue, not the compilation, right? So the PLPG check kind of extension help you do that. But the challenge is those extensions, if you're migrating to a cloud provider, the extension is not supported. So you have to use a self-managed Postgres, take a dump of your code that got converted, rerun the test cases and get that output, and do it on a weekly manner or something. So that the whole goal is to avoid the runtime issue or the first execution issue that can happen at later stage. And an extension like this can help you out. I've not seen any single migration where we don't have to solve performance issue. And when we talk about code, the performance issue is hidden within your code logic, which is within a function or procedure or wherever you're putting it. Now, sometimes it's very important to have some simplest or easiest solution to find those. So over here, I'm just sharing a tips where you can use your pgstat statement extension, which has the track flag, which you can set for your session. Don't try to set it for the DB level, try to set for your session. And then when you rerun the function, it will give you all the nested calls that we have within the function. And one of the sections that I've covered before, every expression, every assignment that you do in PLPG-SQL itself is a query. And you will find those in your nested calls within PLPG-SQL. a simplest way to find the problematic query whenever the issue arises. Okay, so this is also important, right? So see, what happens is whenever a conversion tool is run, it will give you an automated percentage. But now we should all understand that it's not always true that the compilation doesn't guarantee a conversion, right? So it should have its own correctness and efficiency that someone need to measure up. Now what we are trying to just showcase an example is, as and when conversion happen, it's very important to have some test cases. And by the time we move further, we are defining our definition of done. I talk about that in my previous slide, right? Where you have to define a definition of done. So what it means is, as and when working on a conversion, you mitigate all the issues, take the advantage of automated code, deploy it, run some mock test that, which can give you a first executor kind of test in case you're not using extension, and have an understanding based on it. If you have a trigger, we can mock it with a DML, mock DMLs. If you have a view, you can do with a count. It's very important that don't rely on successful deployment, rely on successful execution. It can be first execution, second execution. So as part of conversion, compilation is not the definition of done, but all of the things that we discussed, right? Data type, all of those, they add up an equivalent value for it. And you can have a very simple test cases, which can do some dummy value, test it out your first call. I'm just showing a simple example, but this can be a lot of, so for example, if you're migrating from Oracle, you have a packages. Packages can have n number of code. Now all of those become independent code in Postgres because we don't have a concept of that in Postgres. Now testing each one of those is very important, right? So you should have some form of test cases. I'm not saying a functional test cases, but at least something that can give you a first executor behavior. I'm just sharing a very sample example of test cases, how simple it can be, but it's very important to have those. So over here, if you look at overall conclusion, right? So your definition of done, as I was saying, it's not always compilation. It's basically align with every plan that you have put, convert object in sequence, use your PLPG inbuilt feature, and always have your first executor. And this is the last slide that I want to edit, right? So not a marketing slide, but just want to show how easy the migration is. You have to do a lot of steps for code conversion or data migration, and it involves a lot of decision. So the whole thought process is be very proactive when you talk about code. Don't rely on conversion tool. Build your own definition of done and wrapper on top of it. That will basically help you accelerate the overall migration. Thank you. I can take questions if any. A procedure was introduced in 11. That's a very good question, and I get that a lot. See, actually, we had procedure in Postgres before 11 also, and it was called function. It's not that the procedure is doing something that function cannot. I can have a function which return void and do exactly the same thing. The only difference is how you want to do transactions. And whenever you write a code, you want to have a transaction which guarantees that the whole code was successful or the whole code was failure, that the whole rollback happened. And with procedure, you just get a feature where you can do commit and rollback. But if you ask me, I'm still in favor of using functions in almost all the cases, except where you do batch-wise commit. Those cases you can go for procedure, but remaining cases where your transaction termination guarantee that the whole code runs, you still can do it in function. And function give you both better return type. You can have set of values, multiple out, multiple ref cursor. Procedure out parameter is still not mature.
Yeah, how about lobs? Can you migrating the lobs? Like
logs.
Lob. Large objects.
Large objects. So lob basically primarily come as part of the data type. So it goes to either text or the byte family. And it's very important to understand that if it is a character log, you can still use text data type and do all the string function in Postgres. But in Oracle kind of system, you still have to use DBMS lob kind of packages. So if it is a CLOB, you can use all the string case. If it is a byte, then you have to use the byte-based data type. And I think for CLOB, we have a better feature in Postgres. The only caveat is you cannot have a CLOB more than 1 GB. That's a limitation. You have to be well aware of it. But other than that, most of the things are supported.
Hello. Yeah. So if you're migrating from Oracle to SQL Server,
Oracle too?
no, so Oracle or SQL Server to Postgres, would you recommend using PL PGSQL, or would you recommend like PL Python, PL Perl? Like what was your recommendation regarding PL PGSQL and the?
See, it depends on the effort that it took, that will take for you to write in PL Python for your PL SQL. If your PL PGSQL exhibit a lower effort as part of %, and your PL Python, so if I have a very limited code logic, and I have a team that knows Python well, it's fine to do it. But problem with Python is that, I'll talk about in general for all cloud provider. Cloud provider don't support untrusted language. So if you have a PL Python you cannot compile a function of that kind in RDS or all of those cloud providers. So you have to be conscious about those limitations as well. Because managed service will not give you an untrusted call that you can do from all of those. But you're free to choose any language. It all depends on the expertise of the team, the time that you have to do that modernization. And PLPG is favored more for database folks, because if it is maintained by a database team, they are more comfortable with the technology that is within the database. But Postgres doesn't distinguish on the language. It's up to you what you choose.
Yeah. Package name dot function name. How would you handle that syntax?
Which one?
In Oracle, we have functions nested inside a package, right?
Okay.
So how would you name those functions in Postgres?
So if you follow a standard open source tool like Oracle PG, you can migrate package as schema, put all of those code in that. But when you move anything in schema, you have to also take care of grants at that level. Some conversion tool migrated as an individual object. So you append the package name and all. I am in more favor of using it as schema.
As a schema, right? Yeah. Thanks.
You mentioned that a bit we have Boolean on the Postgres side. I'll introduce later in the overhead. So after making a data type mapping from bit to Boolean on the Postgres side, and then we go after conversion, we go with the migration. So when we go for the direct insert, right, for the 0 and 1 into the Boolean, so that won't allow me unless I put it under the
Data type.
under codes, that 0 and 1.
No, 0 and 1 is supported directly as Boolean as far as I know. See, the Boolean support lot of value. Boolean support yes, no, TF, 0 and 1. I don't know 0 and 1 in codes is supported or not, because that becomes text and Boolean casting.
And the codes it supports.
Okay, I'm not sure about that.
Not the other way.
Not directly? No. I think it is the vice versa, as far as I understand. I'll check it. It's a quick test that we can do, yeah.
Yeah. So I have a question, right? Let's suppose we are migrating from Oracle to Postgres in AWS, right? So we have a schema conversion tool, like most popular.
Correct.
So what level of correctness can we expect, or like?
See, over here I'm not saying how good a tool is as part of conversion.
Right.
Hence I emphasize more on post-automatic conversion output, right? A tool can say it converted 90% of it, but your first executed result 20% of conversion only. So it's not a tool that does it, it's the team that drive that conversion. It's the people the skill that people bring, not the tool automation.
Correct. So in such cases, I think it would be good to have it replicated over another on-prem or before just going directly, right? So that would be the approach, or like?
It depends on, so if you put on-prem, right? Not every team, so for example, if you put on-prem and you want to, your actual target is to go on RDS, but you're initially putting an on-prem, you have to take care of implementing all the dependent extensions and all the developer machine, and it create a lot of caveat. And at the same time, if you're running a production on a cloud managed service, it's very important to do development also on that service. Okay. You cannot do a development or self-manage and expect a production run on RDS. So the compatibility should be from the phase 1 or day 1.
So apple to apple has to be
yes,
there.
yeah.
Thank you.